All right, welcome. Today, we're going to peel back the layers on a pretty amazing scientific paper, one where a tiny mistake, a complete accident, actually led to a brilliant breakthrough.
So let me ask you something, just to get us started. What if you built this really specific trap for one thing, but by pure accident, you ended up catching something way more valuable?
Well, believe it or not, that's pretty much exactly what happened to a team of researchers over in India. And their surprising catch got published in the Journal of Chromatography B. You see, they set out to build this really specific molecular trap for a compound called naringin. But right there in their own paper, they say it themselves. In an unexpected turn of results, their trap actually had a much stronger pull, a higher affinity for a totally different molecule.
Okay, so why is this a big deal? To get why this mistake is so important, we have to talk about something you and I probably throw in the trash without a second thought: onion peels.
I mean, think about it. We eat a ton of onions worldwide. They're the second most consumed vegetable, and all those onions create mountains and mountains of peel waste. And that's actually a problem, right? It smells, it decays really fast, it's a real environmental headache.
But what if all that waste wasn't really waste at all? It turns out those peels are absolutely packed with a super powerful antioxidant called quercetin. And get this, the peel, the part we throw away, has 77 times more of this stuff than the actual onion we eat. That's just, wow. It's a gold mine hiding right in our compost bin.
So, the big challenge is, how do you get this valuable quercetin out of the peels? But here's where the story gets really interesting. Remember, the scientists didn't start by trying to catch quercetin. They started by building a trap for that other molecule we mentioned, naringin. To do this, they used a really clever technique called a molecularly imprinted polymer, or MIP. Now, the easiest way to think about this is like making a custom lock for a very specific key. You take your key, the molecule you want to catch, and you build a polymer, kind of like a plastic shell, right around it. Then you wash the key out, and what you're left with is a perfect key-shaped hole, a lock designed to catch only that one molecule. So here's the play-by-play for how they built their version, which they made magnetic so it's easy to handle. First, they take their template key, that's naringin, and mix it with these little building blocks called monomers and a magnetic core. Step 2, they blast it with ultrasound to make all those monomers link up and form a solid shell around the template. Step 3, they just wash the naringin away. And what's left? A perfect magnetic trap shaped exactly like naringin.
And you can really see the transformation here. On the left, you've got the plain magnetic core nanoparticles they started with. Pretty simple stuff. But look at the image on the right. That's the final polymer. It's this complex, almost web-like structure. It's a totally different material, custom built for one job.
Okay, so now they've got their trap. It's magnetic, it's perfectly shaped to catch naringin. They could have stopped there, but, good scientists always push a little further. They decided to test it against a few other molecules, just to see what would happen. And that is when they found their big surprise.
And this chart just says it all. Look at this. The trap was built for naringin, right? That's the middle bar. It caught about 4.9 milligrams. Not bad. But then look at the bar for quercetin, 8.5 milligrams. It was almost twice as good at catching the molecule it wasn't designed for. I mean, that's just wild.
So the question is, how on earth did that happen? Well, it all comes down to the shape and chemistry of the molecules. Naringin, the one they used as the template, is kind of big and bulky. It has these large sugar groups hanging off it. But quercetin, it's smaller, more compact. And here's the real kicker. It has 5 of these special binding sites, these hydroxyl groups, while naringin only has 2.
So think about it like this. The big, bulky naringin molecule made a lock that was maybe a little loose, a little roomy. Quercetin, being smaller, could slip into that lock more easily. And once it was in there, its 5 binding sites could grab on much tighter than naringin's 2. It's like they made a lock for a big clunky key, but found a smaller, sleeker key that actually fit better.
So now, purely by accident, these scientists have this amazing super selective trap for the most valuable thing in onion peels. It was time to put it to the real test. Could it work on actual, messy, real-world onion peel extract? And the answer was a resounding yes. This graph is a little technical, but it's really cool. The bottom line shows the raw onion extract. It's a messy soup of all kinds of different chemicals. But the top line? That's what came out after they used their magnetic trap. That one huge, clean peak, that is almost pure quercetin. They literally fished the treasure right out of the trash.
And it gets even better. For any of this to be useful in the real world, it has to be efficient, right? Well, look at this. They could reuse the trap over and over. After 2 full uses, it was still at 96% strength. Even after 3, it was still at 90%. That's a huge deal. It means this isn't just a cool lab trick, it could actually be practical.
So let's step back for a second and think about what this all means. Because the big takeaway here goes way beyond just onions.
You know, this story isn't really about onions. It's about something much more profound called scientific serendipity. It's about those happy accidents, those unexpected results that end up leading to something way bigger and better than what you were trying to do in the first place. It's a beautiful reminder that science doesn't always move forward in a straight line. Sometimes the most important discoveries happen when you're looking for something else entirely.
And that's the thought I want to leave you with. If this incredible, valuable compound was just hiding out in something as common as an onion peel, it just makes you wonder, doesn't it? What other amazing secrets are we just throwing in the trash every single day?